Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. So in this question, we basically need to add the 2 3/4 and the 2 2/5. So we're going to do 2 3/4 plus 2 2/5. Now, if I just rewrite this, 2 3/4 can be written as 2 plus 3/4 plus 2 plus 2 1/5, or 2/5. So we can add the two 2's together to make 4, and then all we need to do is add the 3/4 and the 2/5. So when you add two numbers with different denominators, what we need to do is get the common denominators. And we do that by just quickly writing out the 4 and the 5 times table and seeing what the first number in both their times tables is. 16, 20, and 5, 10, 15, 20. So that's 20. So we need to get the bottoms of the fractions to 20. Now for 3/4, to get the bottom to equal 20, we need to times the 4 by 5. And whatever you do to the bottom, you've got to do to the top, so times that by 5 as well, which will be 15. And for 2/5, we'll get that bottom to 20, so we times that by 4. And so we've got to times the top by 4 as well, to make it 8. So it's going to be 15 over 20 plus 8 over 20. So we need to add the numerators. So it would be 15 plus 8, which is going to be 23 over 20. Now that is a top-heavy fraction, so we can rewrite that as 1 3/20. And we can add the 4 and the 1 together to make 5 3/20. So the answer is 5 3/20. So Factorise means to put it into a bracket, and it looks like it's a quadratic here, but it's actually just a linear factorising because we don't have a number term. So we're going to just use one bracket for this. And looking at these terms, I'm going to focus first on the numbers. So 20 and 30, I can divide both of those by 10, and that will leave 2 and 3. So that's the numbers done. Next, I'm looking at the t terms. So we've got t squared there and a t there. So we can divide out a t, but that will leave a t on the first term. And finally, I'm going to look at the u, and there's just a u on both of them I can factorise out, and actually that just leaves nothing on the inside of the bracket. Now, always when you do this, expand the bracket to check if you've made any mistakes. So I'm going to do smiles and rainbows. There's loads of different methods. So 10 times 2 is 20, t times t is t squared, and then the u, plus 10 times 3 is 30, times t times u. So we know we've got the right answer. So our answer is 10tu brackets 2t plus 3. So when we say y is directly proportional to x, what we mean is whenever x doubles, y will double. Whenever x halves, y will halve. Now we've got this proportionality sign here, and to make that an equals, all we need to do is introduce a k constant to the right hand side. So it's y equals something times x. Now to find out what that something is, to find out what that constant is, what we're going to do is feed in the value of y and the value of x that we have. So we're going to feed those in. So y is 55.3 and x is 7. So it would be 7k. And we're just going to put our lines in and solve this. So it's going to be divide by 7 both sides. And 55.3 divided by 7 is 7.9. And that's what k is. So we're going to rewrite this equation here, this formula here, y equals 7.9x, and that is actually our answer. So in this question we're told that the centre of enlargement is at 6, 4. So let's just put across there. And what I'm going to do is just draw ray lines from the centre of enlargement, and we're just going to go through each of the corners of our shape A. And we're going to just check whether it goes through the corner of shape B, which it does on this one. Let's just keep going. Yeah, it does on this one. But it does not on this one. So it says find the coordinate of the vertex of shape B that is not correct. So the coordinate is this one here, and so that would be -4, 1. So the symbol here basically means and the way I remember it is if you draw that symbol and just put a line through it, you can make the word and. So we're looking at the probability of getting something that is in A and C. So the only ones that are in A and C are this 8 and this 9 here. So we're going to just add the 8 and the 9 together, which give us 17. Now we need to then work out how many numbers there are in total, so that's all of them. So 4 plus 8 plus 9 plus 5 plus 8 plus 3 plus 11 plus 6. So we need the total, which is 54. And then we get the 17, and we put that over the amount in total, so over 54. So here we're asked to find how many bread rolls we can make. We've got 89 kilograms, and it takes 0.08 kilograms to make a bread roll. Something we can do is convert these into grams, or we can just keep it at kilograms, but I've got a neat little trick. And the trick is, if you've got a decimal when you're dividing, as long as you do the same thing left and right, you can multiply them by 10 or 100. In this case, we're going to multiply both by 100, because it will make the division a lot easier, because it will make this right hand side, instead of 0.08, it will just make it 8. The reason we can do that is 89 divided by is the same as 89 over 0.08, and as a fraction we can just times top and bottom by 100, so it would be this over 8. So now we can do the bus stop method. So 8 on the outside, and in fact I might use a straighter line here. There we are. And we've got 8,900 on the inside. So 8 into 8 go 1, 8 into 9 go 1, remainder 1, 8 into 10 go 2, remainder 2, and 8 into 20 go 2, remainder 4, and 8 into 40 go 5. Now it says how many bread rolls can we make. Now we can make 1,122 and a half. Well, half doesn't really count, so we're just going to say 1,122 whole bread rolls. Yes, we've got half a bread roll left over, but we are asked how many whole bread rolls can we make. Factorising is the opposite of expanding. So instead of removing things from a bracket, we're actually putting them in a bracket. And so we're going to start off by just putting the bracket down. And we're going to think, well, what can we put on the outside? So we look at the 20x squared and the 35x. And we first of all think of the number. So we're looking for the biggest number that goes into 20 and 35. Essentially, its highest common factor. Well, that's going to be 5. And then we look at the letters. So we look at the most amount of letters we can divide out. Well, this only has an x here, so it's just going to be an x. Then what we're going to need to ask ourselves is 5x times what is 20x squared? Well, 5 times 4 is 20, and x times x is x squared. Then to get the second term in the bracket, we ask ourselves, what times 5 is 35? Well, that's going to be 7. And what times x is x? Well, we don't need an x on the end of that. 5x times 7 is 35x. And you can actually expand that, and you can use any method you want, but I'll use smiles and rainbows. And so we're going to do 5x times 4x, which is 20x squared. and 5x times 7, which is 35x. So our answer will be 5x brackets 4x plus 7. Whenever you have north lines, they will always be parallel. So what we have here is we have a straight line going through two parallel lines, which are our two north lines. And therefore this angle here is going to equal this angle here. And the reason for that is that the two angles are alternate, they're Z angles. So we can say that that is 135, and I always like to try and show the examiner the reasons. So that's because it's alternate angles. And we know also that angles on a point add up to 360. So this red angle represents the bearing of A from B. And so to find this angle out, what we're going to do is just 360 take away 135. And the reason for that is angles on a point equal 360 degrees. And when we work that out, we get the answer of 225. So our bearing is 225 degrees. On a scatter graph, an outlier is a point which doesn't fit the pattern. And as we can see here, all of these coordinates fit kind of a nice line going down there. So they all are showing a trend. But we've got this point here that's nowhere near that trend at all, and that's what we call an outlier. So we know that these are going up in twos, so this will be 28. So the x coordinate will be 28, and this will be 19. So our coordinate will be 28, 19 for our outlier. So if we imagine we've got the 25 meter pipe here, and we've got the 35 meter pipe here. The question's basically asking us, what can we cut all these pipes into, and they all have to be the same length, that will fit with the 25 meter and the 35 meter. And essentially what this question's asking is, what is the highest common factor of 25 and 35? So to find the highest common factor, what we do is we just find the factors of 25, which is 1, 25, and 5, and 5, and the factors of 35, which will be 1 and 35, and 5 and 7. And the highest common factor is the number in both lists, the highest number in both lists, so it's 5. So what we can do is we can cut all of these pipes into 5 meter pipes. So 1, 2, 3, 4, not to scale, and then 7 of these. So 1, 2, 4, 5, 6, and so there's 7 in total. So each of these are 5 meter long, and there's no wastage. And that's the longest we can make the pipes for there to be no wastage at all. So my answer is 5 meters. So the distance initially travelled is going to be 14 kilometers for this stint here. And then we have a bit of a rest. A horizontal and distance time graph is essentially stopped. But then here we start up again to go home. And so that's another 14 kilometers travelled. So in total there has been 28 kilometers travelled. So we're asked to find angle BCE, and that is going to be this one here, because you start at B, go to C, and then go to E, and it's the angle you make. And I might just choose a different colour because we've already got red on here. So we're looking for this angle here. Now my advice for these kind of questions is always just try and work your way around the shape with angles you know. So for instance, I'm going to start with this angle here, and we're going to call this angle ADC. And we know that that must be 79 degrees, and always write down the reason, and we know it is because that is an isosceles triangle. So if you look, we've got an isosceles here, this one, and this one. And the bottom two angles, and I use the word bottom because I always imagine an isosceles as being this way up. The bottom two angles in an isosceles are always equal, so that must be 79. Now we've got two of the three angles in the triangle, and the last one is going to be angle DCA. And to work out what this angle is, we're going to take it away from 180. So we're going to do 180, take away the 279s we've just worked out. And the reason for that is angles in a triangle equal 180 degrees. Okay, so when we do that, we do 180, take away the 158, and we're left with 22 degrees. So we know that this is going to be 22 degrees. And now we can actually work out angle BCE, because it's going to equal angle DCA. And the reason for that is they are vertically opposite angles. So that's just going to equal 22 degrees. Now, it is really common for these types of questions for you to get maybe 1 or even 2 marks for the answer, but 1 or 2 marks normally for the reasons and for the explanations. In fact, I've seen quite a few exam questions where you get 2 marks for the reasons and only 1 mark for the answer. The important thing to realise in this question is that we know a female has been selected. So we can just basically get rid of all of this part of the frequency tree because it's not relevant, because we know a female's been selected. So there's 29 females altogether, and we're looking for the probability that the female chosen at random picked action. So it's just simply 16 over 29. So the rules of indices state that if you have a power inside and outside of a bracket, we just multiply them together. So it's 10 to the power of minus 12 times minus 12. 2 negatives make a positive, and 12 times 12 is 144. The formula y equals mx plus c includes this m, and the m means the gradient. So if we're looking for something that is parallel to y equals 9x plus 18, we're looking at this number here. And for it to be parallel, it needs to have the same gradient. So we could just write y equals 9x plus or subtract anything. Or we could just write y equals 9x. I'm going to say plus 5. So when you read this question, the question's basically asking you to find the bearing of O from B. So the lifeboat is at B, so I'm going to draw a north line here. And to find a bearing, you start from the north line and you keep going clockwise. So we're going to look for this angle here. Now, this angle, which is given to us in the question, and this angle here, which I'm just going to call x, are going to be equal. So x is going to equal 135 degrees. And the reason for that is we've basically got, and I'm just going to draw or extend the north line down, because we've basically got we have a set of parallel lines here, and we have a set of z angles, which we know is alternate angles. So the reason for that is it's alternate angles. And always show the reasons to the examiner. Okay, and so to find out what the bearing is, so the bearing of O from B, it's just going to be 360 take away 135. And the reason for that is angles on a point. We've run out of space. Okay, so we're going to do 360 take away 135, which is 225. And so our answer is 225. A frequency polygon is like a line graph. In fact, it's a type of line graph. but it is when you have the data in a group. So we've got the data here as a group of 0 to 80. So there are 11 at 0 to 80, and then 18 at 80 to 160, and 6 at 160 to 240. Now, where am I going to plot this? It will involve putting a cross somewhere on this graph, and it would seem unfair if I put it all at 0, and it would also seem unfair if I put it all at 80. So what we do is we find the midpoint, the halfway point between 0 and 80, which is obviously 40, and we plot our coordinate there. So it seems to be going up in 2s, so it would be there. So that's at 40, 11, the coordinate. Our next one, we plot at the midpoint again, which would be 120, and it's just halfway between 80 and 160, and it's 18 high, so it would be up here. And then the final one is at 200, and it will be 6 high, so 200 is halfway, and we're looking at 6 high, so it will be here. Then when you're done, you need to join them up with straight lines. So I'm just going to get my ruler, join them up, perfectly straight lines, and there we are. The way I remember what to do here is using KFC. And what the K stands for is we're going to keep that fraction exactly the same, so 2/3. We're going to change, that's what the C stands for, change that divide to a times. And we're going to flip, that's what the F stands for, the 8/7, so it becomes 7/8. Then all we need to do now is multiply the tops, multiply the bottoms, and simplify if possible, so we can actually divide top one by 2 here, and it becomes the answer, which is 7/12. To find out what the value of x is, we first of all have to find out what the value of y is. And we can notice that we've got 2 sets of parallel lines here, and a line going through them. And we kind of got these F angles, which we have to call corresponding angles. So we know that 2y minus 50 is equal to 78. And we must write down the reason, so corresponding angles. And corresponding angles are equal. Now here we've got an equation and we want to solve it, so we get our lines in. We'll go first of all, add 50 to both sides. So we've got 2y equals 78 plus 50, which would be 128. And then we're going to halve both sides, or divide by 2. So we've got 64. So we know that y is 64. And so we look back at the diagram to find out how we'd work out x. Well, what we can do, there's a few different things we can do. We could work out the fact that these two here are vertically opposite. That would be absolutely fine. But actually, if we look at this part here and this part here, these are also 2 parallel lines, and we've got this angle here and this angle are going to be alternate. So I can write that down here. So angle ECB is equal to 78 degrees. So this will be 78 degrees. And the reason for that is alternate angles. And then finally, if we know this is 78 and we know that this is 64, because we know what y is, then we can work out what x is. So x equals 180, angles in a triangle, take away the 78 we know and the 64 we know. And the reason for that is angles in a triangle add up to 180 degrees. And just make sure you write down all the reasons as you go. And when we take away the 78 and the 64 from 180, you get 38. So x is therefore 38 degrees. The rules are that when you multiply two numbers with the same base, and the base is the big number, then all you need to do is add the powers. So we're going to do 6 to the power of 15 plus 4, which is going to be 6 to the power of 19. When working out if two triangles are congruent, which means they're the same, you can either have RHS, which is a right angle hypotenuse side. You can have three sides that are the same. You can have two angles then a side, or an angle then a side then an angle, or you can have a side then an angle then a side. In this question, we have a right angle. We only have two sides, so we can cross this one out. And if you look, that the two sides are next to each other, then the angle. So it's ASS or SSA. So these don't really fit. But the angle is a right angle. So we've got a right angle on both of them. We have the hypotenuse. And we have a different side that are all equal. So the proof here is RHS. So we can write this as a fraction. So it would be 2.84 times 10 to the power of 11 over 4 times 10 to the power of minus 2. What we can do is split this up into two fractions. So 2.84 over 4 times 10 to the power 11 over 10 to the power of 2, or minus 2. Okay, so we're going to start by doing 2.84 divided by 4. So we're going to just do the bus stop method. So 4 on the outside, and we've got 2.84 on the inside. 4's into 2 don't go, so carry the 2 across. 4's into 28 go 7, and 4's into 4 go 1. So it's going to be 0.71 times, and then the rules of indices say that if you divide two powers of the same base, they're both 10, then you just take away the power. So it's 11 take away minus 2. Now the two minuses, the two takeaways, actually convert to a plus, so it would be 11 plus 2, which would be 13, so it would be 10 to the power of 13. Now we've got a bit of a problem here, because standard form must have a number between 1 and 10, and not including 10, at this position here, and this is obviously less than 1, so we need to convert this into standard form. So what we can do is just write the number out again. So I'm going to write this as an actual number, so it's 10 to the power of 13, so it'd be 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, fill in the zeros. So it'd be 7, 1 and all those zeros. And then I'm going to put it back into standard form. Now the decimal point will need to be here to make it 7.1. So it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's going to be 7.1 times 10 to the power of 12. Now, with a bit of practice, you don't need to write out the whole number. You'll be able to just know that if you convert that into 7.1, then you just need to take away 1 from the power. But if you're not sure, and it's not an unreasonable number like 10 to the power of 105, then it's just worth sometimes just writing out the actual number and being 100% sure that you've got it the right way around. So we're told the length of this rectangle is u, and the width is u plus 2. Doesn't matter which way around we do it. And we're told the area is 80. So we can actually write an equation from this. So u times u plus 2, so that's the length times the width, is equal to the area, which is 80. So let's expand this. And what we're going to do is we're going to put everything to the same side. So all I'm going to do here is subtract 80 from both sides. And so we've got u squared plus 2u minus 80 equals 0. Now we're going to be using quadratics, so we're going to factorise this. And so we need two numbers that add together to make 2 and times together to make minus 80. So I'm going to put my brackets out. So we're going to have u at the start of the brackets. And let's have a think. So it's going to be 8 and 10. and one of them will be positive, one of them will be negative. Well, to add them together to make 2, the 10 will have to be positive, and then the 8 would have to be negative. And then minus 8 times 10 is minus 80. Okay, last thing is we get each of our equations equal to, sorry, each of our brackets equal to 0. So we can solve them. Let's just do this in normal colour. So u minus 8 equals 0. And let's solve that. And so we're going to add 8 both sides. And we've got u equals 8. And we're going to do the same for this right hand bracket. So u plus 10 equals 0. Get our lines in. And take away 10 both sides. So u equals minus 10. Now it might get confusing because it says find the value of u, but a length needs to be positive. So this minus 10 is not the correct answer. Our correct answer will be 8. And we can actually check this because if I fill in the value of 8, so we can have 8 at the top here, and 8 plus 2, which is 10. 8 times 10 is 80. So we know that we've got the right answer. Y is inversely proportional to x means that y is proportional to 1 over x. And I'm going to change that for an equal sign by timesing the right hand side by k. And k represents our constant. And we're told that when x is 5, y is 10.8. So I'm going to fill those in. I'm going to substitute those in to be able to find out what k is going to be. So it'll be k over 5. And we're going to be solving this. Let's get my lines in. And solve it, I just times by the bottom of the fraction. So times both sides by 5. And we're going to end up with 50.4 is equal to k. So k is 50.4. I'm going to rewrite this equation here, but we know what k is. It's 50.4. We're asked to find the value of x when y is 9. So we've got 9 equals 50.4 over x. And whenever in this situation here where we've got the unknown at the bottom of a fraction and we've got it equal to a number, what you can do here is actually just swap these around. Effectively we're timesing both sides by x and dividing both sides by 9. But it does really help us out here because it just says that x is equal to 50.4 over 9. We can just do that on the calculator and it gives us 5.6. So when we're doing column vectors and adding and subtracting them, we just literally add and subtract the top and bottom numbers. So a plus b minus c will be, just looking at the top, 9 plus 18 minus 9. 9 plus 18 minus 9, which will equal 18. And the bottom will be 9 plus minus 18, so really minus 18, and minus 9. And so that will be minus 18. So our column vector will become 18 minus 18. We're going to start by focusing on the A and B, which is 8 and 16. So in the middle is going to be 8 and 16. The next thing we're going to focus on is the fact that A is all the multiples of 4. Now 8 and 16 have both already been taken because they're in the middle. So the remaining multiples of 4 are the 4 there and the 12 there. So the next ones I'm going to focus on is the A or B. So A or B is in A, in B, or in the middle. So if we cross out the ones we've already used, so we've already used the 8 and 16 and the 4 and the 12, that leaves the 1 and the 9. We'll cross that out of our other list. And there's only 2 left in our everything list at the top. We've got the 3 and we've got the 11. So on the outside we have 3 and we have 11. So we need to first of all work out what the length of the side of the square is. And to do that, what we do is we get the 44v to the power 4, w to the power 5, and we just divide it by 4. And to do that, all we need to do is just divide the coefficient by 4. So it'd be 11v to the power 4 w to the power 5. Some people will try and do something with the v to the power 4 w to the power 5, but if you think about it, if I just draw out my square, if it's 11v to the power 4 w to the power 5 all the way around, when you add, you don't add the v to the power 4 w to the power 5, it's just going to be 11 lots, another 11 lot, another lot of 11, and another lot of 11. So it's 44 v to the power 4 w to the power 5 in total. And to work out what the area is, we obviously are going to square that. So we're going to do 11 v to the power 4 w to the power 5, and we're going to just times it by itself, which is what squaring means. Okay, so we're going to times the 11s together, so that's going to be 121. Going to times the v to the power 4s together, and remember with indices, if you times two powers of the same base and they're both v, then we just add the powers together, so that'd be 8, and we're going to add the w to the power 5s together, so that makes 10. So it's 121 v to the power of 8 w to the power of 10. First thing we notice is that there is a square here, so we can work out what this length is going to be. It's also going to be 40 centimeters. And whenever we're working out the area of a shaded area, we're normally working out the area of two shapes and subtracting one from the other. And this question's really no different. So we're going to start off working out the area of the square. And all we need to do now for that is 40 times 40, which will be 1,600 centimeters squared. I normally only put units in our answer. The next thing we're going to do is work out the area of the circle, but to do that we need to work out what the diameter of the circle is, and if you notice that the diameter of the circle is just 40 degrees. It's the same as the width of the square, or height of the square. So if the diameter is 40 degrees, the radius would be 20 degrees. So for the circle, for the area of the circle, we're going to do pi times the radius, which is 20 squared, and 20 squared would be 400, so this will be 400 pi. This question's asking us to leave it in terms of pi, so we're going to do that. Now next we're going to work out the all of the corners, so that includes these three here and this one. So I'll say, like, I don't know, 4 corners. Just try and explain to the person marking my exam what I'm doing. And to do that, we're just going to do the square, take away the circle. So 1,600, take away 400 pi. Now we can't actually do anything more than that. That is our answer. So it's just, we just leave it at that. And to work out just the shaded bit, which is this bit here, they are 4 equal amounts that we've got for these corners. So just one corner, which is the shaded bit, will be the 4 corners divided by 4. Now we've got a kind of fraction here. We can divide all of the terms by 4. So that will leave 1 at the bottom, 100 pi here, and this will be 1,600 divided by 4 is 400. So we're just cancelling the fraction, and actually we leave it as 400 minus 100 pi, and that indeed is our answer. You can't simplify that any further. So to answer this question, you need to just know the answer off by heart. There is a diagram that can help us actually get there. And if we just draw a right angle triangle and put the lengths as 1, not right angle here, we can use Pythagoras, a squared plus b squared equals c squared, to work out the fact that this is going to be root 2. Because it's an isosceles triangle, this angle here is going to be 45 degrees, and same with the bottom right one, but we're not interested in that. When we label it with our marked angle here, we've got the adjacent is here and the hypotenuse is here. Now we know from trigonometry that cos x equals a over h. The angle is going to be cos 45, and a is going to be 1, and h is going to be root 2. Now, this is a bit of a strange one with 1 over root 2, because we need to actually be able to rationalise the denominator. And basically what that means, if you haven't done surds yet, or you aren't doing surds, is you times Tom1 by root 2. And so we end up with root 2 over 2. So if you ever see 1 over root 2 is absolutely fine as an answer, but if you ever see the answer as root 2 over 2, the two are actually exactly the same. So writing 1 over root 2 is fine, or writing root 2 over 2 is also correct. So we're asked to solve f of x equals 23, but it tells us that f of x is 10x plus 3. So all we're really doing is 10x plus 3 equals 23, and we're just doing a simple solve. So get our lines in, and we're going to take away the 3 both sides, which will give us 10x equals 20. Then we're going to divide the 10 both sides, and that just gives us x equals 2. So our answer is 2. First thing I'm going to do is add these column vectors. So we're going to add the tops first, and then we're going to add the bottoms. So it's plus minus 14. And so at the top it would be minus 4, and 11 take away 14 is minus 3. Then I'm going to pick a point on my shape, and the the top one tells us how far right we're going. So we know we're going 4 to the left because it's obviously a negative. So we're going to go 1, 2, 3, 4. The bottom one tells us how far up we're going. Well, it's going to be down because it's a minus 3. So 1, 2, 3. And we can do that for each of the other points. So 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. And when we've done that, we can join them all up with straight lines. And label the new shape B. To add column vectors, all we need to do is add the tops and add the bottoms. So 3 plus 7 is 10, and 4 plus minus, or just 4 minus 5, is minus 1. So our answer is 10 minus 1. First thing I noticed with this question is we've got this nice triangle here, and we've got this kind of missing angle here. So we're going to work out what angle BCA is by doing 180, take away the 110 plus the 15, which is going to equal 55 degrees. And you need to write down the reason, and the reason you'd write down is angles in a triangle add up to 180. So this is 55 degrees, and the circle theorem says that when you have two angles coming from the same chord, so this angle and this angle are both coming from this chord here, they are going to be equal. So we know that x is going to equal 55, and that will be our answer. But you must write down the reason. And the reason is angles from same chord are equal. A box plot starts with the lowest value, then it goes to the lower quartile. So we have the lowest value, then the lower quartile, and then we have the medium, then the upper quartile, and then the highest value. So lowest value is at 1 on this one, and normally we just put a little kind of line at the end here. So we're going to put a line at 1. And I'm just going to put that line there. Ooh, a little bit further to the right. There we go. And our lower quartile is 9, which is kind of where the box starts. So we're just going to start a box there. We're just going to connect these up. There we go. And our median is 11. So we're just going to show that. Quite a thin box plot so far. Now it says the interquartile range is 5. Now the interquartile range is the distance here. So that's 5. So it's going to be 5 more than the lower quartile. If the lower quartile is at 9, it would be 9 plus 5, which will be 14. So if we get our line at 14, and then complete our box plot. Here we go. Now the range is the total distance of, or the total width of our box plot. So that's 17. So that's going to be 17 higher than the lowest value. Now the lowest value is 1, so 1 plus 17 is going to be 18. So I'm just going to, there we are. And we're going to have that at 18. And again, I'm just going to put a line there. We can actually simplify the surd at the bottom. So root 12 is the same as root 4 times root 3. And the reason I've picked root 4 is because it's a square number. So root 4 is 2, root 3. So we can rewrite that as 14 over 2 root 3. We can divide 1 by 2. So that'll leave a 1 there. So it'd be 1 root 3 or just root 3 and 7 there. And when we rationalise the denominator, we times the top and bottom by the square root at the bottom, which will be root 3. And so that's going to be 7 times root 3, which would be 7 root 3, and then just 3 at the bottom. So our answer is 7 root 3 over 3. So to be able to solve this, we want to factorise the quadratic. And to factorise the quadratic, we're going to look at the coefficient of the x squared and the number left on its own, and we're going to multiply those together, so that we're looking at two numbers that equal, what is it, 2 times minus 36 is minus 72, and we're going to look at the coefficient of the x, minus 21, and we're going to look at the same two numbers need to add together to make that minus 21. So what we can do is we can write out the factors of minus 72, add all of them together to find out which one adds together to make that minus 21, or we can kind of do it in our head. So I'm thinking it's going to be 3 and minus 24. Let's just check that. 3 times minus 24 is minus 72, 3 plus minus 24 is minus 21, so that's correct. I'm going to write out this expression, worry about the equation later, but instead of minus 21 I'm going to write plus 3x minus 24x. So I'm just going to replace it for what we've just found out. So it's going to be plus 3x minus 24x minus 36. We might find it easier if we put the negative first, and I probably should have put the negative first, but let's keep going just in case we don't put the negative first. And we're going to do both of these separately, first two terms and second two terms separately. So we're going to factorise them linearly, so I'm going to take the x out of both of these, or divide the x out of both of these. Now here, don't forget the minus needs to be on the outside, so we've got minus, and it's going to be 12, and that's going to be 2x, and that's going to be a positive because it becomes a negative, positive 3. The repeating bracket is one of our brackets, and then the bit left over, so the x minus 12 is our other bracket. So it's x minus 12 and 2x plus 3. To solve now, we get both of the brackets equal to 0, so x minus 12 equals 0. Get our lines in, and we're going to add 12 to both sides. So we've got x equals 12, that will be our first solution. And then we do exactly the same thing for the other bracket. So 2x plus 3 equals 0, get it equal to 0 and solve it. And so we're going to take away the 3 both sides first of all. So we've got 2x equals minus 3. And then we're going to divide by the 2 both sides. So we've got x equals, and we can write it as a fraction, minus 3 over 2 or 1.5. And there we go. The first thing to notice is that 125 is 5 cubed. So instead of 1 over 125, it would be 1 over 5 cubed. And we know that when you have a negative power, it actually turns into the reciprocal of that number. So 5 to the power of minus 3 becomes 1 over 5 to the power of 3. So n is going to be this minus 3. When solving simultaneous equations, when you have the equations drawn graphically, the solutions are just where the two lines cross. So we've got a solution here and a solution here. So the first solution is that x is 0 when y is minus 3, and our second solution is that x is 3 when y equals 0. So with all these circle theorem questions, there's multiple ways of doing it. I'm going to show one way, but if you've got a different way and you get the right answer in correct methods, then please feel free to use that. First thing I'm going to notice is we've got a lot of tangents touching radii. So we've got 2 radii here and here. And whenever we've got a tangent touching a radius, it's always going to be 90 degrees. And so I'm just going to show these all on the diagram as 90 degrees. And then we're going to say angle OBC equals angle OBA equals angle ADO equals 90 degrees. And we have to show the reasons. Most of the marks in this question will be for the reason. So it's going to be a tangent radius equals 90 degrees. And try and write out the full reasons. I'm going to just keep it a little bit contained, just so I can fit this answer all on the same slide. Okay, so the first thing I'm realizing is that there's a nice little quadrilateral here. And whenever we've got quadrilateral and we've got 3 of the sides, we can work out the last one. So angle DOB is going to be 360, take away the angles that we know, so 90 plus 90 plus 48. And the reason for that is angles in quadrilateral add up to 360 degrees. And so when you do 360, take away that, you get 132 degrees. So this is 132. But we also have this angle here, which is also angle DOB, but I'm going to call this kind of the reflex one. And to work this one out, we just do 360, take away 132. And the reason for that is angles on a point equal 360 degrees. And so we're going to do 360, take away 132, which is 228. So this is 228 degrees. Now we can also use the circle theorem to work out this one, because we've got an angle at the centre and an angle at the circumference, and the angle at the centre is twice the angle at the circumference. So angle DFB is going to be 132 divided by 2. Angle at centre twice angle at circumference. Okay, so when we halve that, so 132, and we're going to halve it, so that's 66 degrees. We should really put degrees on these. Okay, the next one we're going to work out is this angle here, which is angle OBF. There's no reason for this, it's just the whole thing is 90. We're taking away the 77, so that would be 13 degrees. So that's a nice easy one. And let's just put the 66 degrees on our diagram as well. And the final final thing really here is that we've got a quadrilateral here, kind of arrowhead, and we've got 3 of the angles, 1, 2, 3, and we're looking for the third one. So angle ODF is going to be 360, take away all the angles that we know, so the 228, the 13, and the 66. And the reason being the same as before, so angles in quadrilateral add up to 360 degrees. And when you do that, you get the answer of 53 degrees. So this angle here is going to be 53 degrees. I'm going to start by getting x equal to the 0.847 recurring. And I'm just going to show that with 3 dots. And we want to bring forward everything that's not part of the recurring pattern. So what I'm going to do is I'm going to find out what 10x is. And that's going to be 8.4747. So what I've done is I've just got the recurring pattern after the decimal point. And what I want to do now is bring forward one of the occurrences of the recurring pattern, so the 4 and the 7, just one of them. So we're going to times it by 1,000. We'll find out 1,000x, and so it'd be 847.4747, etc., etc. Next, I'm going to take away everything. So 1000x take away 10x, and that's going to be 990x, and then 847.4747, etc. Take away 8.4747, etc. It's just going to be the same as 847 take away 8, because the recurring stuff will just cancel each other out. So 847 take away 8 is 839. And now I'm just going to put my lines in. And so what I'm going to do now is just divide both sides by 990. And so on the left hand side we've got x, and on the right hand side we have 839 divided by or over 990. So as a fraction it's going to be 839 over 990. So we need to start here by rationalising the denominator, because notice that the answer it wants is not in a fraction. So we're going to write out the question, which would be root 8 plus 50 over root 2. And we're going to times top and bottom by the surd at the bottom, which would be root 2. And so we're going to have root 2 brackets root 8 plus 50 over, and then root 2 times root 2 is just going to be 2. And we can multiply out these this brackets. So root 2 times root 8 is root 16, which is actually just 4. So it would be 4 plus, and then root 2 times 50 is 50 root 2, all of that over 2. And then we can divide top and bottom by 2 to get rid of the fraction. So that'll leave a 1 at the bottom, or just get rid of the fraction. 2 here. Now notice you've got to do all 3 terms. So we've got to divide this by 2 as well. So our answer will be 2 plus 25 root 2. And it won't be over 2 anymore because we've got rid of that. So it's just not going to be a fraction. And so A would be the 2 and the B would be the 25. So we're told to complete the square, so we're just going to get this equation here and just complete the square for it. So the first thing I'm going to do is remove the coefficient of the x squared. So we want just x squared and so on. So I'm just going to make a set of brackets, and we're going to factorise it out of the x squared and the minus 24x, so that would be minus 8x. Then we've got the take away 15. Next I'm going to complete the square, so I'm going to do this in different colour just so we can see what's happening. And to do this we have a bracket with an x minus half of the coefficient of the x, so that'd be 4 squared. Now if we expand that we get x squared, brilliant, minus 8x, fantastic, and then we have a plus 16, so we need to remove the 16, so we're going to take away the 16. Next we're going to expand the bracket with the 3 in. So we're going to have 3 brackets x minus 4 squared, or close bracket squared, minus 48 minus 15, and then we're just going to tidy that up by adding the numbers together, so that would be minus 63. On our graph, we're going to draw the graph of y equals 3x squared. Okay, simple. And we don't need to, it's only a sketch, so we don't need to worry about exact values, but we do know, the most important thing is we know it goes through the origin, so it hits here at 0, 0. That's the important thing, okay? Because we know that if we called that f of x, then the situation we've got here, well, it's going to be f of x minus 4, okay, because we've got the minus 4 there. So that means it will move to the right 4, okay, and it will also, we've got to worry about that minus 63 as well. And if we had f of x minus 63, we know it goes down 63. So in total, we have f of x minus 4 take away 63. That's what we have in total. So we're moving just 4 to the right and then 63 down. So instead of 0, 0, our minimum point will be at 4 minus 63. We've got to subtract 1 outside the function, so all that means is we move the graph down 1. So instead of here, it's going to be down 1. Instead of here, it's going to be down 1. This bottom bit here will be somewhere down there. And just everything will be down 1. So it's not that easy to sketch, but we'll try our best to sketch it out. And we want to draw exactly the same graph, just down 1. It's always important with these questions to realise what the normal graph will look like before we have a look at what the new function will look like. So it's always good to remind yourself what a y equals sine x graph looks like, and it fluctuates between 1 and minus 1. If I write a minus 1, and it goes up first of all at 90, goes back down at 180, down to minus 1 at 270, and then back up at 360. So it's just a simple sketch to help us figure out what's going on with the transformed one. So first thing I notice is there is a negative here, which just means it will be flipped in the x-axis. So this would become like this. And there's also a 2 there, so we're multiplying all the y coordinates by 2. So instead of this going down to minus 1, it will start by going down to minus 2, and it will go up all the way to 2. So we've got a nice idea of how this will look, and so we're going to just start plotting this now, I think. So it will go down at 90, which is, so there, to minus 2, back up to 180 at 0, and then back up to 2 at 270, down to 360, and then it will just go again, 540, up there, and then back down. Not the perfect, not the best graph I've ever drawn, but I think the examiner will understand that I know what the graph will look like, so don't panic about making too many mistakes when you're drawing curves. Just try your best to get it as low as possible, but don't go back and start feathering the lines or anything. To find the inverse, we're going to first of all, instead of writing f of x, I'm just going to replace it with a y. And the trick of finding the inverse is to swap over the x and the y. So we're going to swap them over. I'm just going to do it over to the right hand side over here, so we've got a bit of space. Now the challenge is to get it so that it's y equals rather than x equals. So we're going to start off by multiplying both sides by 4. and that will give us 4x on the left hand side, and it will get rid of the fraction on the right hand side, which was kind of the point. Next we're going to get rid of that minus 6, so we're going to add 6 both sides. And then finally we're going to get rid of that times 5 there by dividing both sides by 5. So we've got 4x plus 6 over 5 equals y. And we use y as a replacement for the inverse function of x. And so we're just going to say the inverse function of x, which is what that minus 1 means. It means inverse, equals 4x plus 6 over 5. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.